and I'm delighted to be here on behalf of the University of Illinois Center for Advanced Study to welcome you to this virtual George MillerComm event. And this afternoon, we are thrilled to have Dr. Peter Gleick, who will be speaking to us about the past, present, and future of our water. But first, let me acknowledge that our institution is on the lands of the Peoria, Kaskaskia, Piankashaw, Waya, Miami, Mascoutin, Ottawa, Sauk, Muskogee, Kickapoo, Potawatomi, Ojibwa, and Chickasaw nations. These lands were the traditional territory of these nations prior to their forced removal. And these lands continue to carry their stories, the stories of these nations and their struggles for survival and identity. And as a land-grant institution, the University of Illinois has a responsibility to acknowledge the people of these lands, as well as the histories of dispossession that enabled the growth of our institution for the last 150 years. So I invite us to just reflect on and address these histories and the role that the university has played in shaping them. And this acknowledgement and this centering of Native peoples is a start as we move forward. And second, it's my honor to tell you a little bit about George Miller, who is the man who, along with the whole range of co-sponsors, makes these events possible. So George Miller was born in 1863. He received his PhD in 1893 from Cumberland University in Tennessee. And he taught at a range of institutions, Michigan, Cornell, and Stanford, before coming here. He was the author of more than 20 publications. He was well known for his work on the theory of finite groups. At one point, he was the president of the Mathematical Association of America. And he was utterly devoted to this university and to the field of mathematics. He was very unassuming. He was, despite his reputation as a world-recognized mathematician, no one guessed that he had more than meager savings. But when he died in 1951, he left an estate of almost $1 million to the U of I that was to be used for educational purposes. And he's said to have remarked, "Everything I have, I received from the university, and I simply want to repay my obligation." And we are so very grateful for his generosity. Now, the hallmark of a CAS MillerComm event, whether a lecture or performance, is its broad appeal across the disciplines. And I know that you will find this clearly demonstrated today. Indeed, there are few issues that we could talk about which are so crucial for the future of our planet. So let me now hand over the mic to Professor Steve Witt, who is Director of the Center for Global Studies, who will be introducing Dr. Peter Gleick.
And good afternoon, everyone. I'd like to give a special thanks to the Center for Advanced Studies for sponsoring this MillerComm lecture. As you may be aware, this event is also part of the combined Joint Area Center Symposium and Spring 2021 iSEE Congress on the Future of Water. I'm Steve Witt, Director of the Center for Global Studies at the University of Illinois, and it's my pleasure to introduce today's distinguished speaker, Peter Gleick. This lecture is a part of a joint effort of the Illinois Global Institute and specifically 5 centers that are funded by the U.S. Department of Education's Title VI National Resource Center program. Throughout this year, each center has included a focus on issues of water within its programming as part of the Joint Area Center Symposium, or JACS. This year, the centers and the Institute have enjoyed a fruitful partnership with the Institute for Sustainability, Energy, and Environment to bring you today's speaker and this series of lectures and discussions. We are especially grateful to have renowned experts to join us virtually this spring to discuss water, a most precious resource for humans and all of Earth's inhabitants. Water is not only a basic human need, but also serves as a critical input for energy and food production, as well as ecosystem services, which in turn affect human livelihoods and well-being. Climate change is leading to increased hydraulic variability with a significant impact on the hydraulic cycle, water availability, and water demand at the global, regional, and local levels. Before I introduce today's keynote speaker, We are very proud to announce that this keynote talk and the whole Congress for 2021 series is certified green in accordance to iSEE's Certified Green Events Program. I invite you to take a look at the slide on the screens to read a bit more about the program, if that slide's there. If not, you can check it out on the iSEE Congress website. COVID has certainly helped us decrease emissions by eliminating the need for transportation to and from a venue. And of course, we're saving potential food waste and other energy and resources as the events are all virtual. But regardless of circumstances, the Sustainability Institute is invested in making sustainability and environmental stewardship a part of every event. I hope that the conversations, questions, and ideas generated as a result of the event spark a growing interest in helping preserve the planet that we all share. And now I'd like to offer a few words about today's keynote speaker, Dr. Peter Gleick. Peter is a leading scientist, innovator, and communicator on global water and climate issues. He co-founded the Pacific Institute in Oakland, one of the most innovative, independent, non-governmental organizations addressing the connections between the environment and global sustainability. His work has redefined water from the realm of engineers to the world of sustainability, human rights, and integrated thinking. He pioneered the concept of the soft path for water, developed the idea of peak water, and has written about the need for local water movement. Among many other honors, Peter received the prestigious MacArthur Genius Fellowship, the U.S. Water Prize, and has been named a visionary on the environment by the BBC. He was elected in 2006 to the U.S. National Academy of Sciences. In 2018, he was awarded the Carl Sagan Prize for Science Popularization. Peter is the author and editor of many scientific papers and books, including the World's Water series, Bottled and Sold, the story behind our obsession with bottled water, and a 21st Century U.S. water policy. He's here today to present the past, present, and future of water, looking back at fresh water's role in human evolution, our planet's current water crisis, and his sustainable vision for the future. Please join me in welcoming today's speaker.
Well, thank you, Stephen. And first, let me start by thanking the university, the center, Stephen and Tamara, for your introductions. I'm very happy to be here. As Stephen mentioned, it's sort of a strange time. I'm sorry I'm not here in person. These in-person meetings where I get to talk with people in the breaks and meet them are wonderful. And the Zoom era, the pandemic era, has put a stop to that, perhaps temporarily. On the other hand, I have to admit, I'm not sorry not to have to get on another airplane. So there are some environmental advantages and some travel advantages of the current situation. But anyway, thank you for joining me today. It's morning where I am. It's afternoon where you are. It's perhaps evening where some of you are. And also, I want to say just at the beginning, welcome to Earth Day. It's almost Earth Day, a couple more days. For some of us, every day is Earth Day, but it's a chance to reflect on some of the serious environmental challenges and potentially environmental solutions that we have in the coming years. As you mentioned, I'm going to talk about water, the world of water, the past, present, and future of water. Let me share my screen here. I have some slides that will accompany my talk. Hopefully you can see all of these. And let me start really with a short summary of what I'm going to say so that you have a sense of where I'm going. First of all, there's a very serious global water crisis in many forms, in many places, and that's what brings us to today. I believe that we're in a transition to freshwater sustainability from an era of unsustainable water management and use. I think the shift from where we are to where we want to be is going to be slow, although I believe it's happening. I have to acknowledge that bad things are likely to happen between where we are today and where we want to be. But I also believe that we can accelerate that shift, that sustainable transition from a bad present to a more positive future. And I'm going to talk about each of these things. I'm going to talk about the crisis that we face, and I'm going to talk about that transition. We live on a water planet. Very little of the world's water, unfortunately, is fresh and accessible to humans. That large blue dot there is the total volume of water on the planet. The littler blue dot is the fresh water that's available to us, a tiny fraction of the total water available. And even much of the world's fresh water is not truly accessible to us. It's locked up in the ice caps of Greenland and Antarctica. It's locked up in deep groundwater, and the total amount of fresh water that's available to humans for our use is just a little fraction of what's here on the planet. I'm going to describe the nature of the world's water problems and a path forward to solve them, but just a quick reminder of the importance of a modern water system. I think, as Tamara said in her introduction, water connects to everything that we care about. It's a sort of a perfect example of the nature of global resources and the importance of global resources to what humans actually care about. Water's connected to public health. It's connected to forest issues. It's connected, of course, to agriculture and the production of food. It's connected to the nature and the health of our environment. And there's a strong energy connection. It takes water to produce and use the energy we need. It takes energy to produce and use the water that we require. And of course, water is an infrastructure issue. So water is one of those issues that ties together so many of the things that we care about in other fields. And water is interdisciplinary from an academic point of view. It's an engineering issue. It's a natural science issue with hydrology and geosciences. It's connected to economics and the way we plan our cities and make plans for the future. It's connected to politics, and it's connected to law. And I'll talk a little bit about each of these things, but from an academic perspective, water connects to almost every department in our universities and ought to be and could be taught in each of those departments. So here's just a little cartoon. This is what most people know about where our water comes from. We know that somewhere out there, it's raining. And we know that when we turn on our taps, we get clean, fresh water. But what happens in between is a mystery to many people. And the more we know about what's going on in this middle box, the more likely we are to think more carefully about how we manage and use our water resources and how we invest our money in protecting and providing safe water for everyone. And if we could fill in this box for people from an educational point of view, from a communications point of view, we're much more likely to work harder to protect the water resources that are so important to us. So a little bit about the global water crisis. There are many pieces to this, but if there was any single piece of the global water crisis that for me is the most important, it's the failure to provide safe water and sanitation for billions of people on the planet, the failure to provide basic human needs for water. And it's the most inexcusable problem, and it's the worst of the problem. It's the 21st century, and yet there are still huge numbers of people worldwide that don't have access to something I would suggest everyone listening today takes for granted, and that is access to safe water and sanitation. It's the idea of water poverty, the failure of society to spend the relatively small amount of money required or to apply the technology that we understand and have developed for a century or more and made the fundamental commitment to provide safe water and sanitation for everyone. And the reality is, it's not just a developing country problem. We've seen in the United States, in our communities, in the Central Valley of California, the failure to provide safe water and sanitation for everyone. In Flint, Michigan, thousands of people were exposed to lead and other contaminants after failure of the water system and the failure of local governments to manage that water system in a safe and equitable fashion. And as I said, here in California, where I live, we have hundreds of thousands of people, primarily in the Central Valley of California, and primarily uh, 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 Latino communities, underrepresented, under-resourced communities that have the same problem, that are drinking water contaminated, in this case, with too many agricultural chemicals, that don't have access to safe water and sanitation. One of the consequences of our failure to meet basic human needs for water and sanitation are water-related diseases: cholera, dysentery, typhoid, guinea worm, schistosomiasis, and millions of cases of these diseases every year, preventable almost in their entirety, and almost entirely children under the age of 5. Millions of cases of deaths of water-related diseases every year, and probably hundreds of millions of cases of the diseases themselves, again, associated with the failure to provide safe water and sanitation for everyone. Another piece of this puzzle is water pollution, the massive contamination of our freshwater systems with industrial and human wastes. To some degree, the start of the environmental movement in the United States was in part to protect water. This is an old image from 1952 of the Cuyahoga River in Ohio catching fire from industrial wastes. And it had caught fire many times in the years previous to that. And then a major event in 1969, again on the Cuyahoga River, when the Cuyahoga River helped stimulate the public movement for clean water. It helped stimulate the passage of the Clean Water Act and the Safe Drinking Water Act, two major pieces of federal legislation here in the United States, at a time in the late 1960s when the environmental movement was growing anyway. But this event, a major water pollution event from oil spills on the west coast of the United States in Santa Barbara, from offshore oil drilling, all of those things helped push the environmental movement into the mainstream. And it, as I mentioned, helped lead to some of the major legal protections we now have in the United States for safe water. But even today, we still have massive water pollution problems, not just here in the United States, but worldwide. This is a photograph from toxic algal blooms in Lake Erie in just a few years ago, because we've not gotten nutrient pollutions under control in the Great Lakes and the Mississippi Basin and other basins in the United States. We've addressed some of our water quality problems, but not all of them. And there's much more that needs to be done. And this particular toxic algal bloom on Lake Erie shut down the water supply for the city of Toledo, Ohio for a few days, because the city's water system was not able to handle the toxic algae that was produced at the time. Of course, water is a food issue. Without water, we have no food. 80% of human withdrawals of water go to the agricultural sector, but a substantial portion of that water comes from unsustainable groundwater overdraft. By some estimates, 30 to 40% of global food production comes from unsustainable overdraft of groundwater, the overpumping of groundwater faster than nature recharges that groundwater. And that can't continue. And yet we have to grow more food for more people in the coming years, or get better about what we grow and where we grow it and how we grow it, and how our food system delivers what we grow to hungry mouths. So water is a critical issue for the production of food, and our current system is, quite frankly, unsustainable. We know that many of our worst ecological problems are associated with our use of fresh water, the fresh water that humans extract from the systems for our own use. Freshwater ecosystems cover less than 1% of the Earth's surface, but they contain a third of known vertebrates, including about 40% of the world's fish species. The Freshwater Living Planet Index, a measure of the health of freshwater ecosystems that represents nearly 3,400 species of birds, fish, amphibians, mammals, and reptiles, has declined by 83% since the 1970s, a collapse described by some ecological groups as catastrophic. 80 freshwater fish species are known to have gone extinct, 16 of them in just the past year. And so ecosystem problems are another piece of the global water crisis that faces us. We also know that water is a political issue. Half of the land area of the planet is in what we call an international river basin, that is, a river shared by 2 or more countries. And growing water scarcity, growing populations, growing demand, growing economies, means growing tensions over water. This is a graph from the Water Conflict Chronology. It's an open source database that I maintain at the Pacific Institute. And if you Google Water Conflict Chronology, or if you go to worldwater.org, the website listed here, you can get access to that database. The database contains over 1,000 water conflict events going back more than 4,000 years. This is a graph that just shows from 1980 up until about 2018 or 2019, actually, the number of water conflict events per year recorded in the water conflict database. And it shows a couple of different things. First of all, it shows a great increase in recent decades in the number of conflicts associated with water, the number of violent events associated with water. But it also breaks out those conflicts in 3 categories that we describe. Water as a weapon of conflict, where water systems or water resources have been used as a weapon in conflicts that start for other reasons, perhaps. The red category is water as a casualty of conflicts, where water or water systems have been targeted during conflicts that start for whatever reason. Conflicts start for ideological reasons, economic reasons, religious conflicts, ethnic conflicts, but where water or water systems were casualties of those conflicts. And the blue category is where water resources have been a trigger of conflict. The idea that water scarcity, control of water, has been a trigger of the conflict itself. And of course, we know we're changing the climate. The science about climate change is strong and unambiguous. Every National Academy of Sciences on the planet, every professional scientific organization agrees on this. Humans are changing the climate. And I know that other talks you'll hear will focus on climate, but among the worst impacts of human-caused climate change, and I'm a climate scientist in part by training, will be impacts on water resources. Changes in water availability, changes in water quality, changes in rainfall patterns, and increases in evaporative demand for water as temperatures go up. Extreme events like floods and droughts are going to get worse and worse, and in fact are already getting worse and worse. And this isn't a future problem. These impacts are already being observed. But there's another piece to this. Water is very closely tied to energy. As I mentioned a little bit at the beginning, it takes water to produce energy that we use, and it takes energy and greenhouse gases to produce and clean and use the water that humans want to use. A very substantial amount of our personal energy footprint turns out to be associated with collecting, treating, distributing, and then using in our homes the water that we use. If we can reduce the energy and greenhouse gas footprint of our water system, while also preparing to deal with the now unavoidable consequences of climate change, that is an important step forward on the policy side. And again, just to highlight some of this, this is a graph of 800,000 years of carbon dioxide in the atmosphere, recovered from ice cores in Antarctica, and it shows a lot of different things. Here on the y-axis, you can see the atmospheric concentration of CO2 in parts per million, going back 800,000 years up until the present today. And you can see that natural climate variability produces ups and downs in the CO2 concentration in the atmosphere. This is the natural changes in climate that we understand from orbital dynamics, changes in the tilt of the Earth, changes in the dynamics of planetary cycles, and these are natural changes. When CO2 was high in the atmosphere, around 250 to 300 parts per million, we were in a warm period. When CO2 was low, the Earth was in an ice age. But today, the atmospheric concentration of CO2 in the atmosphere has exceeded 415 parts per million. This rapid, dramatic, unprecedented increase in CO2 concentrations in the atmosphere is the human fingerprint of climate change. And this is unprecedented. The amount of CO2 in the atmosphere today is higher than it's been not just for 800,000 years, but for 3 to 5 million years. And we know extreme weather is getting worse, one of the consequences of human-caused climate change. Here's another graph that shows that. This shows natural catastrophes on the rise from 1980 to 2019. The orange line is total number of natural events, that is hydrologic events, meteorological events in green, climatological events in red. And the vast majority of these events are related in some way to the water cycle. And furthermore, these data, which come from the insurance industry, which keeps track, as you might imagine, of natural disasters like this, says the only plausible explanation for the rise in weather-related catastrophes is climate change. That's a challenge that we're going to have to deal with for many, many years into the future. So that's the crisis we face. The next question really is, what do we do about it? And the rest of my talk will address this, but let me summarize this by saying we're not going to solve our water problems with the infrastructure, institutions, strategies, with the thinking that we used in the past. What we need is a transition to a new path for water. And let me describe that new path. Let me put this in the context of what I call the soft path for water. And let me argue that it's time for 21st century soft path water solutions. And by the soft path, let me contrast that with what I think about as the hard path. That is what we did for water in the 19th century and the 20th century leading up to today. The hard path said, let's build for water supply. Let's find more water. Let's take more water out of our groundwater systems. Let's pump more water out of our renewable rivers or out of the lakes that provide the water supply for us and build for water supply. The soft path, and I'll go into a little more detail about each of these, but the soft path says, let's rethink what we mean by water supply. We know we're overdrafting our groundwater. We know we're taking all of the flow of the Colorado River now, and even if we wanted more, or the Yellow River or the Nile River, we can't have any more. But let's rethink what we mean by supply and find alternative supply solutions. The hard path says, let's satisfy a projected water demand, growing populations, growing economies. The assumption has always been growing demand for water. The soft path, and very importantly, the soft path says rethink water demand. What do we mean by demand? And I'll come back to that as well. The hard path says water is an economic good or a commodity or a private economic good. The soft path says water is an economic good, but it's also a human right. And how do we balance water as an economic good and water as a human right? The hard path built centralized water treatment systems. We collect our wastewater, we send it to a centralized water treatment, and it produces one quality of water. And often we throw that water away. The soft path says protect source water quality, first of all, and then let's match the quality of supply to the quality of water we need. We don't need potable water to flush our toilets or to water our lawns. And the soft path might also argue, I have to point out, maybe we don't necessarily need to water our lawns at all. But protecting water quality and matching quality of supply to quality of need is another way of thinking about this issue. The hard path gave no thought to ecosystem water needs or health. We didn't understand the implications for ecosystems, or we didn't care. The soft path says we absolutely have to protect ecosystem needs and ecosystem health as part of a sustainable solution for water. And the hard path had a set of centralized management institutions with limited public participation. Water utilities, primarily engineering focused, primarily male dominated. The soft path says we have to rethink our institutions. We need community participation. We need more flexible, integrated water institutions that don't just think about water, but think about water and energy, or think about water and energy and food together, or think about water, energy, food, and the way we plan our cities together. So different kinds of institutions. These are the characteristics of the soft path. And they don't say don't build infrastructure like we did in the hard path, but they do say we have to rethink a great deal about what we did in the 20th century. So specifically, we have to recognize the human right to water. The UN has declared a human right to water. We're making progress on water and sanitation under what we call the Sustainable Development Goals, a global set of goals for addressing water poverty and sustainability, of which water is one of them, SDG 6. But we must do much more to provide safe and affordable water for all, for 100% of the world's population. The failure to meet basic needs, as I said, isn't a technology or an economic problem. We know how to do this, but we have simply failed to mobilize adequate resources. It requires different and greater commitments on the part of government and communities, and recognizing the human right to water as a fundamental strategy moving forward. We have to invest in infrastructure. This is a graph that shows the drop in cholera death rates in the United States when we introduced infrastructure, water treatment and distribution in the early 1900s. In around 1909, we introduced the first chlorination and wastewater treatment in Jersey City, and then very rapidly in major cities around the world. And cholera and dysentery, frankly, disappeared in the United States when we started treating our water supply and our wastewater. So we do need to continue to invest in infrastructure in places that don't have that investment around the world. But we also need to invest in infrastructure here in the United States. We're not adequately maintaining the infrastructure that we have. And President Biden's infrastructure plan in part acknowledges that, with hundreds of billions of dollars, in part for water-related issues here in our cities, on native lands, in disadvantaged communities, and upgrading the infrastructure that we built but have not been upgrading in the past few years. I said we have to rethink supply. We certainly have to develop new sources of supply, but it can't come from our overtapped rivers and groundwater. And we have to think differently about providing the drinking water that we need. The good news is there are plenty of options. We can supplement old sources of supply with new ones. We can capture and treat wastewater to a very, very high standard, frankly, to potable drinking water standard, and use it to supplement our water supply. And they're doing that in Singapore today. They're doing that in Israel today. They've been doing it in Namibia for 30 years or longer. We're doing it in California, where we're collecting and treating more and more of our wastewater to potable supply, and then we're beginning to reuse it. We can capture more of our wastewater and more of our stormwater that comes in short bursts in our cities and replenish groundwater. We're doing that more and more. And we can desalinate water. As I said at the beginning, 97% or more of the water on the planet is salt water. It's too salty to drink. It's too salty to use for agriculture. But we know how to desalinate that water. It's extraordinarily expensive. It has a high carbon footprint if we use fossil fuels to run our desalination plants. But we already, in many parts of the world that have no alternatives, are turning toward expensive desalination as an option, and it remains an important option. And if we can do it in an environmentally sound manner, if we can afford it, if we've done the other things that are more cost-effective first, it remains an important piece of the puzzle. So there are new ways of thinking about supply that don't require more extraction of overused sources today. On the demand side, let me ask what's really just a rhetorical question. What's the first thing we do when we have a leaky bucket? And the truth is our water systems are in effect leaky buckets. And before we put more expensive, high quality, potable water in those buckets, we need to plug those leaks. We need to think about where we're losing water in our leaky systems, where it's being used wastefully or inefficiently, because every gallon of water that we provide for that leaky bucket that leaks out doesn't just waste water, but it wastes energy. It wastes material resources. It wastes the human effort embodied in collecting and managing and delivering that water. And so the first thing we do has to be to plug the leaks, rather than find more expensive water to put in the top of that bucket. And that's the concept of improving water conservation and efficiency. That's the idea behind rethinking water demand. So let me explain this in a different way that helps me think about this whole idea. We don't want to use water, really, except for the most basic fundamental things like drinking and cleaning and sanitation. What we want are water services. We want clean clothes. We want clean dishes. We want to grow food. We want to make semiconductor chips and goods and services in our industry. And many of those things require water. But the whole idea of rethinking water demand is that almost all of the things that we use water for could be done with less water. That's the idea of improving water use efficiency and conservation. Let's do the things that we want with less water. Let's flush our toilets and wash our clothes with efficient fixtures. Let's grow gardens that maybe aren't single grass lawns, but more beautiful drought-resistant gardens. Let's plug the leaks in the system where they're causing expensive water to be lost. That's the idea behind water conservation and efficiency. And the reality is the potential for improving the efficiency of water use is enormous. We can do much, much more with the water we're already extracting from the system. And this is especially true in agriculture, where 80% of the water that humans use goes. We can massively grow more food with less water, with improved irrigation technology, with soil moisture monitoring so that we're monitoring our soil moisture and only irrigating when our crops need it, with the kinds of crops we choose to grow in the kinds of climates that we have. We are already growing more food with less water, and the potential to do much, much more is huge. And that by itself would have an enormous impact on improving the sustainability of our water systems. We know that we can restore ecosystems. We have to acknowledge the value of our ecosystems, even when our traditional economic systems have failed to do so. And then we have to work to protect and restore those ecosystems. For water, one approach is the restoration of natural flowing rivers, including, for example, guaranteeing minimum flows and removing dams. This is a picture of the Elwha Dam on the Elwha River in Washington State in the Pacific Northwest. It's an old dam. It was built to provide water and a little bit of hydropower for an old logging system, and it destroyed a salmon run on the Elwha River. And a few years ago, the decision was made to remove that dam. It was no longer economic. It was unsafe. The value of that salmon run was increasingly recognized by our economic systems that are beginning to recognize the value of ecosystems. And the decision was made to remove that dam. And this is what the Elwha River looks like today. Salmon runs are being restored. The native fisheries are being restored. The health of the whole ecosystem is being restored. And thousands of small, dangerous, uneconomic dams are slowly being removed in the United States and elsewhere. And it's an indication of what we can do when we recognize the value of natural ecosystems, which again have been ignored for so long in our traditional ways of measuring economics. We also have to build better institutions and management. This is a quote from Nelson Mandela, interestingly enough, talking about water. He said, quote, "It is one thing to find fault with an existing system. It is another thing, an altogether more difficult task, to replace it with another approach that is better." And that's the idea of institutional management reform. the scale of our institutions, the structure, the transparency of our institutions, the integration of our institutions with energy and water and food and planning, as I mentioned, all of these mean managing for sustainability, not for extraction, not simply for expanding supply, managing our institutions for equity, not for exclusion. And finally, we need to reduce the water-related risks of climate change. I've talked already about the seriousness of climate change and the connections with water. If we can cut our emissions associated with water, if we can produce and clean water with less energy or with renewable energy and not fossil fuels, we can cut the emissions of our water systems associated with greenhouse gas and climate change. And that will contribute to reducing the future severity of the climate changes that we face. So the water sector has a role to play in reducing emissions of greenhouse gases. And of course, we need to redesign water management because we know some of the worst impacts of now unavoidable pieces of the climate change are going to be on our water system. So we have to redesign our utilities. We have to think about resilience. We have to think about the vulnerability of our water systems to now a changing climate, not stable climate, which was the past assumption, and plan for what we can no longer avoid. And as an example of this, more than 20 years ago, the American Water Works Association recommended, quote, while water management systems are often flexible, water agencies should re-examine water system design and operating rules under a wider range of climatic conditions than traditionally used. That was more than 20 years ago. The water system itself, the water community itself said, basically, we have to redesign our water systems for climate change. And we've not done as much as we need to do, and that's something we need to accelerate moving forward. So some final thoughts. The water crisis is real, it's bad. There are human, economic, and environmental costs to doing nothing about the freshwater crisis. Not everything is getting worse, and new thinking is needed. What solutions are sustainable, scalable, and socially responsible? How do we apply existing and new technologies to address this? How do we think about economics in a new way to provide for more sustainability? And how do we design and implement smarter, more integrated institutions? There are examples of all of these successful stories out there. I believe that we're in a transition already to a positive future for water. You know, we have the past, we have the current present crisis, but the future could be, and I believe will be, sustainable, but we have to move faster. We need new actions, we need new commitments, we need new partnerships, we need new communication and social outreach tools to help us move in the right direction toward sustainability. So thank you very much. I think we have a little bit of time for questions, and I'd be happy to, if there are some, to share some thoughts. Here's my contact information. And again, happy Earth Day to everybody.
I'll go ahead with a question for you, Dr. Gleick, and thanks again for doing this. We have a question that says, how are major coastal cities preparing for potential climate change impacts?
Yes, so I haven't talked much about sea level rise because, of course, I've been focusing on fresh water, but it's a good question in the sense that sea level rise, which is one of those now unavoidable consequences of climate change, also has very significant freshwater impacts, freshwater coastal ecosystems. It turns out the vast majority of our wastewater treatment plants, certainly those on the coast, are built at sea level, because what we do is we collect wastewater, we treat it to a pretty good standard in most industrialized countries, and then we throw it away, we dump it in the oceans. And so part of what we have to do to adapt to now unavoidable climate change impacts is think about coastal issues and dealing with wastewater treatment plants on the coast, and how do we manage infrastructure in general on our coast, including either building coastal protections or ultimately retreating from those areas that are most vulnerable or most likely to not be protectable in our cities and our rural areas. It's going to be a growing problem for not just freshwater, but for coastal communities around the globe.
Thank you. We have another question from a person that says I really enjoyed these soft path water solutions. More specifically, does soft path mean shifting infrastructure-centric water solutions to human-centric or community-centric solutions?
Yes, it absolutely does. Although, let me be clear, there are absolutely places around the world where literally hard infrastructure, concrete infrastructure, treatment plants, dams for flood control and drought protection are still needed, water distribution systems. So we have to build those systems in a different way than we built in the 20th century. We built dams without caring about ecosystems or about upstream or downstream communities. That era has to be over. But what we have to do is we have to combine existing infrastructure with decentralized kinds of infrastructure, wastewater plants that are built in small scale in community that permit water reuse in that community. There are all sorts of ways of doing better with the infrastructure we have, and especially bringing communities into the decisions about the kinds of water systems that meet their needs. For water and sanitation, one of the things we learned was in the 1980s and 1990s, we had very well-meaning non-governmental organizations and governmental organizations going into communities and drilling wells and putting in pumps and then leaving. And the community was unable to manage that infrastructure. They didn't have the technology to fix those pumps when they broke. And it was when we learned that community management of those systems was important, that those kinds of community systems became much more sustainable, much more beneficial to the communities themselves.
We had a question. Can you provide any specific examples of more democratic water institutions that may address the issues you've raised? I'm wondering if there's a water equivalent of community choice aggregation that you have in the California energy sector.
So, of course, one of the challenges with water provision, like with many sort of standard utilities, is water's a monopoly. There's only one set of pipes coming to my house. And so we don't have traditional choice when it comes to utility operations, which is one of the reasons they're monopolies, which is one of the reasons why we have public utility commissions that are, in theory, providing oversight to those monopolies. And so one of the ways that we can move to more democratic participation is making sure that our water utilities have public participation on their boards, and our public utilities commissions have publicly elected officials that are responsible to the demands and the needs of local communities. That's what we didn't see that in Flint, Michigan, where the local institutions were not responsive to local needs. And we need more and more of that. The example I gave previously of public participation in developing countries, in communities, in developing the kinds of water systems that they have and the control and operation of those water systems is another good example where those systems become much more sustainable when the local communities are involved in designing and managing those operations. That's one of the lessons of the 20th century that we need to expand much more widely in the 21st century.
Thank you. Another question. With this all hands on deck call to identify solutions to water crises, what role do you see from the study of past water systems investigated by historians and archaeologists?
Yeah, so I'm actually writing about this now. I could have talked much more about the past and the long history of the development of water systems from, frankly, ancient Mesopotamia through the Romans and the Greeks up until the design of the modern systems we have today. And the truth is, we learn from the past. Hopefully, the mistakes that we made in the ancient water systems that we built, where initially we didn't understand the role of lead in public health because our water systems had lead, up until the crisis that we have in Flint, Michigan, where there are still communities, hard as it is to believe, in the United States that have lead in their water systems. Those are old mistakes that we should have fixed a long time ago, to the kinds of management systems that might have worked in the 1900s and the early 2000s, but we know could be improved upon today. We're learning from the past, and that's the way that we improve the systems in the future. Again, the hard path for water brought enormous benefits to us, but we learned that ignoring ecosystems was a big mistake. And that's one of the things that we have to correct moving forward. You know, we learned that there's an economic value to water, but water is a human right, and we need to provide basic water services independent of ability or not to pay for those water services. You know, the rich should pay for water, the poor should, if they need it, get subsidized water and sanitation. And designing those kinds of new changes in economics is something that we've learned from the past, but lessons we've not yet fully integrated in the future.
Dr. Gleick, you've already touched on soft systems a little bit, but here's another question. Do you think we'll see a removal and replacement of the gray or hard infrastructure we use today in our water systems? Or will these infrastructure systems stay in place but be augmented or integrated into new soft systems?
I think it'll be a mix. Again, centralized water treatment systems are wonderful, but the design where you treat water to a high standard and then throw that water away, that's outmoded. Water is just too valuable to be thrown away. It's not a liability anymore, it's a resource. And so modern water treatment systems now ought to be developed with the ability to capture that treated wastewater and reuse it in some form for agriculture, for ecosystem restoration, for groundwater recharge, or even ultimately for potable use. So new water treatment systems ought to integrate water treatment and reuse. Our cities ought to be designed, they used to be designed to take stormwater when it rains intensively and to get rid of that water as soon as possible to avoid flooding. But increasingly, we're learning that we can capture stormwater and use it for certain purposes. Capture it, store it temporarily, use it for groundwater recharge. For example, in the southwestern United States and Los Angeles, we're beginning to think about redesigning our cities to capture stormwater and reuse it rather than divert it and get rid of it as soon as possible. So those are some examples of things where the kinds of infrastructure we've built can be modified, new similar infrastructure can be improved upon. Those are all going to have to be part of the equation.
Thank you. And we have another one that's somewhat related, soft solutions as well. How might standard setting and reporting play a role in rethinking our approach to water management? Is it ineffective if we don't first implement the soft path solutions?
Another great question. The truth is a lot of our water issues are not technological, they're governmental, they're management, they're regulatory. For example, we have a Safe Drinking Water Act in the US that in theory protects the quality of our drinking water. We have a Clean Water Act that in theory protects wastewater discharge and sets standards for industrial water treatment. But those water laws are old and outdated. They need to be updated. Everybody has known for a long time that many water contaminants are not regulated under the Safe Drinking Water Act in the United States. So we need smart economics. We need smart institutions. We need better regulations in certain situations. There are contaminants like PFAS, is what we call the forever chemicals, that are not regulated and ought to be regulated. The process for adding new contaminants to the Safe Drinking Water Act is slow and outmoded. And of course, in the last 4 years, there's been no interest in updating those regulations. That's something that the Biden administration has said they would take on, and that it is responsible for improvements at the EPA. But so regulations is another piece of that puzzle, as is, I would note, enforcement of regulations. In many places, and this isn't true just for water, it's true for lots of things in the environmental world, sometimes we have regulations, but we don't adequately enforce them. So smart regulations is a piece of the puzzle, smart enforcement is a piece of that puzzle, and that's related to the way we rethink and manage our institutions.
Thanks. And one last question we have. How do we deal with entrenched interests that prevent the kinds of solutions that you're proposing? I'm thinking in particular of intensive irrigation agriculture in southern Spain. The farm lobby is powerful, so proposals for example, charging higher prices for water usage for agriculture in order to more completely reflect the true cost and encourage less waste, et cetera, have not been possible because of the farm lobby.
Yes. So again, as I said at the beginning, water is often a political issue. And the challenge there is dealing with complex politics. Of course, we have that problem in the United States. In the Western U.S., 80% of the water, like globally, goes to agriculture. Agriculture has sort of senior water rights. They're politically powerful, and yet they provide a small fraction of our economy in the West. And so how do we deal with politics? I'm a scientist, I have thoughts about that. Obviously, the more engaged people are at an individual or a local level, the more people vote, the more people get involved in their water boards and their water utilities, the more people address water issues because people care about water. We know that historically, the more likely we are to tackle the political piece of that puzzle. The good news is people really care about water. It's more and more true. If you look at polling, water issues are among the most important issues for people. That's been true for decades. Water really polls very, very highly. And so challenging entrenched political issues is one of the challenges that we have moving forward. But I think we can do so in part because the solutions are there, because the way to move forward on these positive examples are there, and we just have to make them better known. We have to use tools of communication and social media. We have to talk to our politicians, and we have to push to move forward.
Thank you so much, Peter. This has been a wonderful talk, and we appreciate your time and illuminating words, and especially your willingness to answer questions from the audience. I'd like to thank everyone for attending. Please note that our next event is also a MillerComm Lecture, and it will offer a look at the global grand challenge of waterborne health threats and new technologies that might help stave them off. This is scheduled for noon this Friday, April 23rd, and it's titled From Polio to COVID, Environmental Virology at its Best, and presented by Dr. Joan Rose, who is the winner of the 2016 Stockholm Water Prize and the Nolan Chair in Water Research at Michigan State University. We hope to see you all then, and have a great afternoon. Thank you.